Okay, so we're going to do a quick video here to show you how to rotate a triangle around a fixed point. Here we have triangle ABC and point P, and we're going to rotate it around point P in a counterclockwise direction. We're going to go, say, about 75 degrees. So in order to do this rotation, we're going to need an angle of 75 degrees. You're going to construct this with a straight edge and with your protractor. To begin that, you're going to make a line segment down on the bottom of the page, somewhere where it's not going to be in the way of your construction. And then with the protractor, you got to use this little crosshairs here and line that up on the vertex of the angle, or where the vertex will be. So that's the end of the line segment right now. Counting from 0, you're going to go up to where you find 75, in between the 70 and 80, put a little mark right there, and then you're just going to connect that dot to the vertex of the angle. So there's a nice 75-degree angle for me to use for my rotation. So the way this construction works is we're going to utilize the fact that in a rotation, all of these points have to stay the same distance from the center as they are right now. So since B is closest to point P, I'm going to begin there. If I place my compass on point P and I open it up to the distance from P to B, right? So just holding the compass with the point on center on P and the end on point B, I know that point B prime has to be somewhere along that arc, because it's not going to get any closer or further away from the center of the rotation. So somewhere on there is point B prime. The only question is where. To figure out where, I need to copy this angle over to here so that I can see where point B prime is going to end up. Now the first step in this copy is to use exactly the same distance I'm using here. Without changing the compass, we're going to bring the center from point P down to the vertex of the angle over here. We're going to put the very same arc right through the angle. Okay? So that's that same radius arc as I used over here, but centered at the new angle. Now I want to point out here what's going on. I'm trying to copy these two rays over to here. So I'm going to draw in a line that I don't always draw in class, and that's the line actually connecting P and B. So I'm going to make it red just to show that it's not really part of the actual construction, but it might help you to see what's going on. So that line segment right there, you can think about as being this piece of the angle, this part of the ray. You can think about point B being right here, point P being right here, and what we're looking for is when we rotate around that 75, we're looking for where B prime is going to end up. Now B prime is what I'm looking for over here. I don't have it yet. So I know it's got to be somewhere on this arc. To locate it precisely, I'm just going to measure the distance from this B to that B prime, because that's got to be the same as the distance from my B to B prime. All right, so you see what we're doing here. We're taking the distance of this arc where it intersects the two rays of the angle, and we're just going to copy that distance over here to B and put a little X marks the spot. That is B prime. It's as easy as that. So I'm going to put a little dot there, and I'll label that B prime. And I'm also going to draw on the other side of that angle just to help you see it. Again, this isn't a necessary part of the construction, but it's a nice way to remind yourself what's going on. All right, these are the two rays of that 75-degree angle that we just copied from over here. And the one I just drew in there is this other side right down there. So once I have B prime located, I'm well on the way to finishing this construction. I still need to locate A and C, and the way I'm going to do that is very much the same. I'm going to take advantage of the fact that the distance from P to A isn't going to change during the rotation. So if I set my compass up open to the distance from P to A, I know that somewhere on that arc has to be the point A prime. The only question is where? Well, to locate it, I just need a second distance. Since I already know where B prime is, I can use that as a signpost. I'm going to start with my compass on B, open it up to point A, so I'm setting up to this distance, BA, and then that's got to be the same as the distance from B prime to A prime. So I come over here and I mark that distance. Now, notice what happens over here. There are two intersections, one there and one there. And it's a little bit tough to see them too, because this line is kind of slight. Right? So if that happens to you, then what I would recommend you do is go ahead and find the other point first. There's nothing wrong with this construction, but it's a little bit harder to see where the lines are. So if you're ever unsure, find the other point and work backwards to A. So I'm going to focus on C for a minute. Just like A, I know that C isn't going to get any closer to or any further away from the center of the rotation. So that means that point C has to be this far away from C prime. Or excuse me, point C prime has to be that same distance away from the center, which means C prime has to live somewhere on this arc. Right? Again, the only question is where. To find out, I just need a second distance. So if I go from B to C, okay, so I measure the distance from B to C, I know that has to be the same as the distance from B prime to C prime. So again, C's got to be somewhere on that arc. I know the distance from B to C has to be the same as the distance from B prime to C, so I use that to locate C prime, right there. Now that I know where B prime and C prime are, I can actually use this new point to figure out which of those two intersections is the correct one for A prime. See, because I know that A has to be the same distance from C as A prime and C prime are. So if I set my compass up to the distance from A to C, and then I head over here to C prime, then that distance has to be constant again, and I can put an arc right there. And you can see that that very clearly rules out this second intersection over here. A prime has to be right there. So I can go ahead and mark that, A prime. I can take my straight edge and draw in the sides of my triangle here. And of course, when you're doing a rotation, keep in mind that a rotation is an isometry. Since it's an isometry, that means that the shape you begin with and the shape you end with should be congruent. So take a minute and just visually take a look at your triangles. Does ABC look congruent to A prime, B prime, C prime? The easiest mistake is if your A was over here instead of at the first intersection at that second, but you should be able to tell that that triangle changed if that was the case. It would be much wider, and that would be an obtuse angle instead of an acute angle. And that's all you need to do to rotate a triangle.